Okay, for our next example of our polynomial inequalities, you're going to notice, oh, we finally have a leading term that's negative. Now, the author says, well, we should always keep this positive. So we're going to divide by everything by a negative 1. So when you divide inequalities by negative 1, that's fine. Just don't forget to flip the inequality symbol. So again, we want positive y's. So we're going to have positive, we're going to have closed circles, and our right-hand behavior will start out as a positive x. So the author says it's always good to have your leading term be positive. That way your right-hand behavior is always positive. And I agree with that. But I run into students who will divide by a negative and forget to flip the inequality symbol. And when we get done with these two examples that work with a negative leading term, I'm going to show you you really don't have to divide by negative 1. So let's get this done. So next, what I'm going to do is I'm going to start to speed this thing up. Okay? So if we know we have x to the 4th, then let's go to the number line and put in 4 tick marks right now. And if we know we have equal to, then we have closed circles. Put your closed circles up there. And we know we have x to the 4th, so the right-hand behavior is positive. Put a positive over there. Alternate your signs. And we know we want positive y's, so shade the regions. And just like that, I know what my answer has to look like. I could literally put in an empty interval where I put blanks where these x-intercepts are supposed to be and say this is what my answer has to look like when I'm all done. So all I have to do now is solve for x. Okay, x squared minus 13x squared plus 36 equals 0. This is factorable whenever your leading power is twice as big as the second power. It's technically quadratic in nature. So two numbers that multiply to be 36 and add up to be a negative 13. How about negative 9 and a negative 4? There we go. We can set these now equal to 0. Add over the 4, add over the 9. Take the square root of both sides. X equals a positive or negative 2 and a positive negative 3. Okay, put your numbers in numerical order. Negative 3, negative 2, 2, 3. Well, put them in your blanks in numerical order. And you're done. Just like that. All right, next example. Oh, another negative. That's okay. Don't panic. Author says, and I somewhat agree, divide by negative 1. But again, you got to remember, once you change all the signs, you have to also change the inequality sign. Okay? And again, we want positive. Our right-hand behavior is positive. So now I have x cubed. I need 3 tick marks. I need 3 open circles because there's no equal to line. I need a right-hand behavior to be positive, and I alternate to the left. I want positive. I shade in positives. I set up what my answer looks like. Open interval, left parentheses, blank, comma, blank, right parentheses, union, left parentheses, blank, comma, infinity. Could it really be this easy? Yes. If anybody talks you into doing more work, leave that person. Tell them to call me. All we have to do is solve for x. All right, here this one could be interesting because 5 is a prime number. So let's see, factor by grouping, take out an x squared, leaves me x minus 1, so I got to take out a negative 5 over here, x minus 1, so x minus 1, and then left over is x squared minus 5. The x minus 1 was the GCF of both of these two terms. Yep, we're going to get a little interesting here. Solving for x, x equals 1, add over the 5, take the square root. So here we're going to have an irrational number. So don't put in decimals, just leave that square root of 5, both positive and negative, in your answer. So the negative Square root of 5 is first. And let's see, who's bigger, 1 or square root of 5? Well, square root of 4 would be 2, so 1's next. Then deposit square root of 5. We put them in our blanks, and there's our answers. You are done. So that wraps up our polynomial inequalities. Oops, get back in there. There we go.